Okay, good afternoon all. I welcome you all for this today's session. Okay, from last few lectures, we are discussing this chapter, Introduction to the Plastics. Before starting the today's session, first I will take the review of previous session, what we have learned in the previous session. After that, I will discuss the points that we are going to learn in this session. Okay, so I will, within few minutes, I will just take the review of previous session. Okay, in previous session, we have started this chapter, Introduction to the Plastics. And in that, we have discussed what is the meaning of plastics. Okay, in that we have studied that the material which is having synthetic or semi-synthetic material and which can be reshaped or remolded using heat and pressure as per your need. Okay, so that it can be, that particular material can be used for various applications. That material is nothing but the plastic material. In that we have discussed its examples like PVC, that is polyvinyl chloride, then nylon, acrylics, polyesters, then polyethylene, polypropylene, and polystyrene. These are some examples of the plastic material. Then we have discussed the properties of the plastics, general properties of the any plastic material. Okay, these are some common properties like low density, low melting point, then low cost. Then these plastic materials are very easy to manufacture, or we can convert them into desired shape and size, and they will provide you the long life. Okay, whichever product is manufactured from the plastic material, it is very much durable as compared to the metallic materials. Then these plastic materials will provide you better strength as compared to their weight. Then they are electrically and thermally insulative. Then they will provide you very good resistance to the shock, corrosion, or chemicals and water. Okay, if they come in contact with different chemicals or water medium, they does not erode. Then their mechanical properties like strength is very good, and they are having very good flowability, so that due to this flowability, you can give them desired shape and sizes. So after this, we have discussed the classification of the plastic materials. Basic two types are there for these plastic materials: thermosetting plastic material, which are known as thermosets, and thermoplastics or thermoplastic materials. And what is the meaning of thermosets or thermosetting plastic materials? Means these thermosetting plastic materials, they can be means after providing the heating, they will melt, and once you harden them, you cannot change its shape again. Okay, you can do this activity only once. Okay, the material which can be once molded and hardened cannot be reshaped or recycled. That kind of plastic materials will be termed as thermosetting plastics. And the plastic materials which can be remolded, means which can be heated again and again, and you can do the reshaping again and again, or repeatedly you can do this activity, is providing heat and reshaping it, and I can do that activity again and again without changing their physical and chemical properties. That kind of materials, plastic materials, will be considered as thermoplastics. Okay, then we have discussed the various properties of thermoplastics and various properties of thermosetting plastic materials. Okay, and at last we perform this activity, that is doing the comparison. Okay, this is the comparison point. Here we have compared the thermosetting plastic materials and thermoplastic materials. And to remember the different comparison points, this is the basic. Okay, this is thermoplastic material structure, and this is thermosetting plastic material structure. Okay, means different molecules are attached here, linked in linear way. Okay, this is one molecule attached to another. In this way, you can observe it. This is linear linking or linear chain formation. And this is present in thermoplastic material. And in thermosetting plastic material, here, these linear chains are again cross-linked. Cross-linking is there. Due to this, what will happen? This, in case of thermoplastic material, the bond between two molecules is weak. Means with a reasonable amount of heat, you can break this bond and easily you can give them desired shape and size. And in thermosetting materials, what will happen? Due to this cross-linking, it is very difficult to break the bond between the molecules. That's why it will take a large amount of heat. Means again, providing heat and reshaping it again and again, it is not possible in this case. The basic reason behind this is cross-linking. And due to this cross-linking, these materials, these thermosetting plastic materials are harder, stronger in nature. Okay? And these thermoplastics are softer in nature if you compare them. Then their tensile strength is also less, these thermoplastics. Okay? And these thermoplastics are easily soluble in organic solvents. And these thermosetting plastics are insoluble in organic solvents. Okay, means depending on the structure only, you can write their properties, you can write their comparison points. Just remember this diagram. Okay, no need to do the mugging of that all parameters and points. Just remember this diagram, and depending on these diagrams, logically you can write there, or you can decide their properties, and you can do the comparison also. Okay, and very simple, simply you can write few examples. In case of thermoplastic materials, whichever your plastic bottles are there, in which that water is stored, drinking water, that will be manufactured with the help of these thermoplastics. Then whichever the kitchen dishes are there. Okay, whichever in thermosetting materials, different applications like some kitchen dishes are there. Okay, maybe some in the form of dish or plates that are made from these thermoset materials, or your electrical switches that are also made from these thermosetting materials. Okay? These are some examples and their comparison points. This part we have discussed in the previous session. Now in today's session, we are going to discuss the 2 points I will try to cover in today's session. The first is the additives used in the plastics. Okay. Additives used in the plastics. Then we will discuss different additives. Some 8 or 9 additives are there that we will discuss. And we will try to cover this polymerization also. What is the meaning of polymerization? In this polymerization, what is the meaning of monomer? And what is the meaning of polymer? Then different types of the polymerization. Okay, and for each type, how the actual polymerization process occurs, means we will discuss the steps involved in the polymerization with few examples. We will discuss few examples also. Okay, this I will try to cover this part in today's session. If not possible, I will extend it in the next session also. Okay, so I will start this today's session. The first part we will discuss is the additives in the plastics. Okay, now these additives are nothing but some chemical materials or some chemicals I'm adding in the existing plastic material to improve its properties so that it becomes more useful for my variety of applications. Are you getting this? Okay, suppose one plastic material is available. I want to improve its strength. Then I will add some other chemical in that. That added chemical to improve its strength is nothing but the additive. I am adding it externally to improve or change its properties, to change the properties of existing plastic material so that that plastic material will become more affordable to me. Suppose sometimes some plastic materials are very expensive. If I used for suppose for manufacturing whole component, I am using that whole material, then it is very expensive or costly. Then what I will do to reduce the cost, I will add some other chemical. Okay, and it does not affect its properties to that much extent. That material I will add it, that plastic material, so that my net cost will get reduced. Then that added material will be termed as additives. You can see here. Now additives are added in the plastics to modify their properties, their behavior, and their overall cost. Okay, due to addition of that additives, what will happen? There will be some change in their properties, their behavior, in the sense of, means their flow characteristics will get changed, or their strength will get changed, and their cost will reduce. So that why I am doing this, why I want to change their properties, behavior, and cost, so that I can use that plastic material for a variety of applications. To use that plastic material, or to means you can say that to enhance the properties, so that it will become more useful. Okay, that's why I am adding these chemicals, which are termed as additives. Now these are some general effects of addition of the additives in the plastic. There are different types of additives are there that I have added in the next slide. Means which additive is added to reduce the cost of plastic material, then which additive is added to increase their strength. According to their properties, types of additives are there. So before that, we will discuss okay. Now if you refer the second point here, I have highlighted, that is the effect of additives on the plastics. When you add, means when additives are added, then what will be the changes, or what is the effect in the properties of that plastic material? These are general effects. Okay, this is the summary. It is not necessary that a single material will provide you all these effects. Okay, it is not necessary. One material can provide one or two effects. So these are some general effects, or you can say that why we are adding additives. These are the reasons. If you add the additives in the plastics, these changes will occur in the plastic material, and it will become more useful. Okay, when additive is added in the plastic material, the first effect is the additive make the plastic material easier to process. Easier to process means it will increase the flowability. Okay, and when flowability of that plastic material is improved, easily you can do the manufacturing process or molding processes on it to give the desired shape and size. From raw material, if you want to convert it in the pipe form or in the form of a coupling, different processes you have to use. And so that processes are become easier, you have to improve the flowability. Are you getting this point? If flowability is improved, then it is become very easy to do the processing. Means you can convert the raw available plastic into desired shape and size. Then when additives are added, they make plastic look good. Look good means its appearance will become attractive. Okay, if you compare different plastic materials, their appearance is very attractive as compared to the other materials. Whichever plastic components are there, it looks very attractive. If you compare chairs, different chairs are available. Chairs are also available which are made from the wood or metal. And if you compare them with the plastic chairs, you can say that plastic chairs looks attractive, or they are available in different colors. Their appearance is very nice. So this is the effect of the additive only. Then additives will save the money. Okay, when you add the additives, it will reduce the cost. Then due to addition of certain additives, that plastic material become safe and sound for handling. For handling of that plastic material, it will become safe. Then it will become clean and healthy. Then it reduces the environmental hazards. Some additives are added in the plastic material to achieve this. And due to addition of the additives, the durability of that plastic material is increased. It means they will work longer. Their life will be more. So these are the effects. These are general effects of the additives on the plastic material. Now we will discuss some specific additives used in the plastics. The first additive used is the plasticizer. Okay. Now, before discussing this point, which type of questions will be there on this MCQ? They will ask you in the MCQs. Okay, these additives will be asked in the MCQs. Direct, if your theory paper is in means descriptive manner, then they will directly ask the short note or like that questions. And if only MCQ questions are there, then MCQ questions will be like this. They will mention you. Suppose which material will be added in the plastic to improve their flow characteristics. Which additive will be added to improve the flow characteristics of the plastics. And below that, 4 options will be there. Fillers, plasticizers, flame retardants, like that. 4 options will be there. Then you have to select the suitable one. So we will discuss that. Means this type of questions will be there based on their effect. Now, these plasticizers, when plasticizers are added in the plastics, it will improve their flow characteristics. Flow characteristics will improve, means that material flowability will be more, so that you can convert them easily into desired shape and size. Means processing will become more easier, and it will also decrease the brittleness of the plastic material. Means that plastic material will become a little softer. So these kind of additives will be termed as plasticizers. Additives which when added into the plastic, it will improve the flowability and reduce the brittleness of the plastic material. That will be termed as plasticizer. And some examples of the plasticizers I have written here. You can say that this is phthalate compounds. Okay, phthalate compounds. These are generally, you can say, are used as plasticizers. You can go through the various examples of that phthalate compound. Some commonly used names I have given here: dioctyl phthalate and diisoctyl phthalate. DOP and DIO. This is the short form. Okay, for example, just you can write this also: phthalate compound. This much is sufficient. Okay. Other examples of these plasticizers are esters, then fatty acid esters, or some kind of alcoholic materials. Okay, or alcohols. This is the alcohol family of one compound. You can add as per your need. Okay. Now, what you have to remember here? What is the effect of this? Or which material you are going to use to improve the flowability and decrease the brittleness? That material will be termed as plasticizer. And few examples. Then second additive used in the plastic is fillers. These are inexpensive material that this is joined. This is single word, no space here. Inexpensive means it is cheap material, you can say that. Okay. It is added in the plastic to reduce the cost. To reduce the cost of the material, to reduce the cost of plastic material, One compound is added and it is termed as filler. It is termed as filler. Then different kinds of fillers used: calcium carbonate, talc, then silica, okay, then wollastonite, clay, calcium sulfate fibers, which are also known as Franklin fibers, then mica, then glass beads, then aluminium trihydride. Okay, if any one or two example you remember, then it is sufficient. Okay, just what you have to try to remember here, its effect. Filler is added to reduce the cost. Okay. Then the flame retardants. This is the third additive. From name itself, you can try to remember from name itself. This filler means we are adding extra material to reduce the cost. Then flame retardants. Retard means, what is the meaning of retard? Retard means reducing. Retard means reducing. Here we are reducing the flame. Means flammability of plastic material is reduced. Okay. These are added to the plastics to reduce flammability of the plastics by preventing oxygen reaction. Okay. What will be the effect of this flammability? If it is highly, you can say that when it comes in contact with the air, it will start, means oxidation process will occur and it will burn. Okay, I want to reduce that property. For that, I am adding these materials to reduce flammability of the plastics. It will be termed as flame retardant. Okay. Here I have added some examples. Halogen atoms. Okay, whichever halogen, there is one halogen family. Chemical elements are there from halogen family. That chlorine, bromine, fluorine. That elements you can add as examples. Okay, halogen atoms. In this halogen atoms, bromine, chlorine, fluorine. That examples are there. They will act as flame retardant. Then we will move towards the fourth additive, reinforcing agents. Reinforcing agents. These materials are added in the plastic to improve their mechanical property. Here, mechanical properties in the sense it will improve its tensile strength. Or in short, you can say for improving the strength of plastic material, we are adding the additives which are known as reinforcing agents. For examples, nylon or glass fibers. To improve the strength, we are adding these materials and these will be termed as reinforcing agents. Then stabilizers. From name itself, you can write its work or its effect. Stabilizers means it will stabilize the property of the material. Now, suppose if you not stabilize a particular plastic material, what will happen? Why this stabilization process is necessary? Why this stabilization process is necessary? Suppose one plastic material is there, and if you have, if you have not performed the stabilization, what will happen? As time passes away, okay, suppose today you have measured the dimension of one plastic part. Suppose its length is 10 centimeters. And after 6 months or 1 year, what will happen? Its dimensions will change. Why it is occurring? Because that plastic material is not stabilized. It will change its properties and it will show that effect in terms of its dimension or any other effect will be there. That's why it is necessary to do the stabilization. Are you getting this point? Stabilization is very necessary. Okay, so whichever elements are added to achieve this stabilization, so that that plastic material can be used for longer life These are termed as stabilizers. And for examples, some carbon blacks are added, or some chemicals like benzophenone is added. Just what you have to remember here, what is the function of this, or why we are adding these stabilizers. And then softeners and extenders. Softeners are added to increase the flow characteristics, means that material will become soft. Okay, and the softeners, okay, the softeners which are liquid in state, that softeners are termed as extenders. Okay, their functioning is same, just name is different. Okay, these extenders are liquid in state, and what is their effect? Due to addition of these materials, material will become, that plastic will become soft, and their flowability will be improved. And some extenders will also act as the flame retardant. Okay, this is the extra property or extra effect given by these extenders. Okay, softeners and extenders are added to make the plastic soft and to improve its flowability. Okay, and when that softener is in liquid form, then it is considered as or termed as the extender. Then we move towards next additive. Then colorants. Okay, colorants is the another additive used in the plastic. Now colorant is nothing but the chemical which will provide the different colors. Okay, plastic material, different colors are there. Now these colorants are divided in two major segments, dyes and pigments. So what is the difference between dyes and pigments? Dyes and pigments, can you tell me? Here one hint is there. These dyes will provide you the transparent colors, and pigments will give the opaque colors. If you have observed the different kinds of paints, paints, in that you can see that dyes and pigments are used. Okay, whichever paint is there, through that paint, or you can say that that paint is transparent. Some paints are transparent. You can see through that layer. If paint layer is given on the wall, you can means that is transparent. You can see through that layer. That colors are nothing but your dyes. Okay, they will give you the transparent colors. And pigments are those which will give you the opaque color, means these are means light will not pass through. Only a dark, thick layer will be observed. You cannot see through it. Are you getting this difference? If dyes are there, you can see through that layer. And if pigment paint is there, then you cannot see through that. Means that it will be considered as a opaque color. Here I have highlighted it. That produces opaque colors, means you cannot see through this. And these dyes, these are used to produce transparent colors. Light can pass through these. Okay, in short, light can pass through these dyes, and light cannot pass through these pigments. Okay, in this way, two types are there of colorants, dyes and pigments, and you can observe these in the form of different paints. Different dyes and pigments are used there. Whenever transparent colors are there, then in that dyes are present, and when that colors are non-transparent, you can say, or opaque, then pigments are used. Generally, these dyes are soluble. Okay, and these are insoluble. In any organic material, these are soluble, and these are not soluble in organic materials. Okay, means to achieve the different colors, these additives are used that will be termed as colorants, and two types of colorants are there: dyes and pigments. Dyes will provide you transparent color, and pigments will provide you opaque color, means non-transparent. Light cannot pass through. Then the last type of additives is lubricants. Now, why these lubricants are added? To prevent the polymer from adhering to the processing equipment. Okay, suppose from raw material you are converting it into the bottle shape. Some raw material is there, or you are converting it into pipes. That raw material may get attached to the equipment, processing equipment. Okay, to avoid that, we are adding lubricant, so that whichever raw polymer material we are using, it should not get adhere, means it will just get stick to the equipment. To avoid that, we are using the lubricant. Then these lubricants are added to provide the better flow. It will also improve the flow characteristics. Then it will prevent the friction between the machines, and it also reduces the machine wear. Okay, machine wear means, if suppose machine is working, there will be friction between two different machine parts. Due to that friction, material loss will be there. That is considered as wear. And when friction is reduced, automatically material loss, that is wear rate, is also reduced. That is the effect of addition of the lubricants. So the materials which are added to achieve these properties or these characteristics, that will be considered as lubricant. And different kinds of lubricants used are stearic acid, then carboxylic acid, then glyceryl monostearate or graphite. Okay, easily you can remember this graphite. Okay, graphite, then stearic acid. So these are lubricants. Okay, in this way, these are additives used in the plastic material. If you are having any difficulty, you can ask me. I will wait for a few minutes here. If you are having any difficulty, you can put that in the chat box. I will take a pause of 1 minute here, 1 or 2 minutes. If you are not having any query, that also you can put in the chat box. Okay, if no query is there, I will move towards the next point, that is polymerization of plastics. Now, to understand this polymerization process, okay, to understand this polymerization process, uh, some basic concepts like monomer, you should be aware of this monomer. What is the meaning of monomer? Okay, it is very much similar to your microstructures in metallurgy. Okay, if you have studied the basic crystal structure, we have learned that unit cell arrangement, body center cubic. I will learn that PCC, FCC crystal structure. What is that? What is that crystal structure? It is basic repeating unit in that material. If a particular material is there, in that material, it is very basic unit, smallest unit, and it is repeated again and again, and it is in large form. Then you can say that that is the overall material. Are you getting my point? Basic unit or smallest repeating unit. एखाद्या मटेरियल मध्ये समजा एखादं मटेरियल आहे, आपण काय करतोय, समजा बॉडी सेंटर क्यूबिक क्रिस्टल स्ट्रक्चर बीसीसी. एक बीसीसी हे युनिट सेल असतात आणि असे हजारो लाखो बीसीसी एकत्र येऊन त्याचं एक मटेरियल तयार होतं. अलग लक्षात. तर सेम इफ you can consider that unit cell as monomer. In case of the metals and their alloys, we have seen that the basic repeating unit is unit cell. Here, your basic and repeating unit is monomer. Okay, monomer is a single unit or molecule which is repeated in the chain. It is single unit. Then it is the basic unit which makes the polymer or plastics. Okay, it is a basic unit, and when number of monomers, suppose this is one unit and this is second unit, it will get attached. Means one monomer is attaching to the another monomer. Like this, chain will be followed. From one monomer, it will attach to the adjacent monomer like this, and whichever chain form is there, that will be considered as your polymer. Okay, monomer is the single repeating unit or molecule that will be considered as monomer, and when number of monomers are stitched together, you can say stitched or joined together, then whichever chain is formed, that chain will be considered as polymer. Clear? Okay, I will read it. I have explained it. Okay, monomer is the single unit or molecule which is repeated in the chain. Single identical unit. It should be identical. Single identical and a repeated unit, that will be considered as monomer. And when number of monomers are stitched or joined together, it will be considered as polymer. Here you can read it. Plastic polymers are formed when small organic molecules. Small organic molecules means which are termed as monomers. Means monomers are stitched or joined or bonded together to form a long chain. And this long chain is termed as polymer. Whichever monomer is there, it is a single building block. Why it is considered as a building block? Because from that single monomer, we are building the polymer. Means you can take the example of construction. If we are constructing a wall of bricks, bricks are there, number of bricks are there. But if you take the single brick from that single brick will be monomer. And when number of bricks come together and they forms a bond, it will form a wall. Are you getting this? that brick will be considered as monomer, single repeating unit. And whichever wall is constructed, that wall will be considered as polymer. Okay, you can remember this. Try to remember this example. From that, you can explain what is the monomer and what is the polymer. Okay, now in the next slide, here some types of polymerizations are listed. Okay, here I have listed 4 types, but basically there are only 2 types. Okay, 2 types are there. I have added 2 extra types, which are that basic 2 types: addition polymerization and condensation polymerization. These are basic types, and another added depending on the mechanism used in that polymerization: coordination polymerization and copolymerization. Okay, different mechanisms are used. So basic types are addition or chain growth polymerization, and condensation or step growth polymerization, and some extra types like coordination polymerization and copolymerization are there, or some subtypes may be there. In this copolymerization, subtypes may be there. Okay, one by one we will discuss this. Okay, so these are 4 types. You can summarize it, or if you write 2 types also, it is also sufficient: addition or chain growth, and condensation or step growth polymerization. And these are extra types: coordination and copolymerization. Now one by one we will discuss them. Each polymerization will have a different mechanism. First we will start with the addition or chain growth polymerization. Okay, first I will tell you the basic concept in this, or basic difference between uh, the addition polymerization and condensation polymerization. Okay, now in addition polymerization, monomers are added together. Okay, monomers are stitched together or joined together without formation of any byproduct. There will not be any byproduct. Okay, in the addition polymerization, no byproducts are formed. But in case of condensation polymerization, different monomers are combined. Different monomers are combined, and during this process, some byproducts are formed. Some byproducts like water or some form of acids or some alcoholic compounds may be formed. This is the difference between addition polymerization and condensation polymerization. This is the basic difference. Means monomers are added together or stitched together without formation of any kind of byproducts. That will be considered as addition polymerization or chain polymerization. And in condensation polymerization, you can say that different monomers are combined. Okay, here we can combine different monomers, but some byproducts are formed. This will be considered as condensation polymerization. Now, these both polymerization processes involve certain stages or steps. From that, we will first discuss the steps involved in the addition polymerization. Okay. These are already points I have discussed. Addition polymerization. In this type of polymerization, the molecules of same monomer or different monomers are added together on the large scale to form a polymer. It means number of monomers are stitched to form a polymer. Now, these 2 points, here they have mentioned the stages. Generally, in addition polymerization, 3 stages are there. The first stage is initiation stage. Okay, initiation, then propagation, and then termination. These 3 stages or 3 steps are there. Initiation, propagation, and termination. And during these 3 stages, what exactly happening, that is highlighted in this point. Here, that particular compound, there will be carbon-carbon double bond. That I will explain with the example. Okay, here you will get confused. I will skip this point. I will tell you that point here. Okay, this is addition polymerization. Different steps are explained here. Different steps are explained here. Okay. Now, the first process is initiation. I require some. Is it visible? Here it is visible. Okay, before this, here they have shown the direct diagram here. This is second step diagram. Means free radical they have shown. Initially, in the process of initiation, what will be there? There will be only, you can see this point. This is ethylene or ethene. Okay, CH2, CH2, CH2. That is ethene or ethylene compound. I think we have studied this. These are types of alkenes. Just this is one example. Okay, this is one example. This is ethene. This is one ethene molecule, second ethene molecule, third ethene molecule. For example, it is shown. Means CH2, CH2. Now, initially, what will happen? This double bond will get break. Okay, if you are able to see it clearly, in this second stage, you can see whichever double bond is present in between these 2 carbon atoms, it is broken in this second stage. In second diagram, this stage is termed as initiation. Initially, that double bond which is present in the carbon atom, it is broken. And how it is broken? It is broken by adding one chemical. It is broken by adding one chemical, and that chemical will be termed as catalyst. It is termed as catalyst. It does not take direct part in the reaction, or it does not combine with that ethene material. What is the work of adding that catalyst? It only initiates the process by breaking the bond, double bond in the carbon. Okay. Now this is the initial ethene, and by adding some catalyst, this double bond is broken. Are you getting this? Double bond is broken now. Now, please refer the second diagram. Okay, now here, after breaking this double bond, here you can see one dash dot I have given. Dot. What is the meaning of this? It indicates the free radical. These are free radicals. Free radical means valency is there. Valency. Electron valency is there. Means it will attack the adjacent molecule. Are you getting this point? Means in the initiation step, what we are doing in that initial compound, for example, ethene we have taken, ethene or ethylene, it is same. We are adding one catalyst chemical, and that catalyst will break the double bond. Okay, here you can see this is the double bond. Forget this OH. Just forget this CH2 and CH2. This is ethene or ethylene. Then by adding that catalyst, what will happen? That catalyst will attack this double bond and that bond will be broken. Now one free radical is formed. Okay, this is the free radical. Now this one free radical will attack the another that ethene material, another molecule. Now this is free radical. It will attack the adjacent ethene. Here you can see this is the free radical. This is the free radical, which diagram I have shown here. Same diagram is here, and it will attack the ethene molecule. This is your ethene molecule. Are you getting this? It will attack this, and it will again break this bond. Here, chain will be formed. Okay. In this way, each molecule, whichever that free radical is there, it will attack to the next molecule and chain is formed. One free radical, it will attack the molecule and chain will be formed. And again, new free radical will be formed. It will attack the next molecule. Like this, the chain will be formed. Are you getting this? This is the addition or chain polymerization, chain type polymerization. Means initially, double bond between the carbon is broken by adding one catalyst. And as double bond is broken, free radicals are formed, and these free radicals will attack the adjacent molecule and chain will be formed. Okay. So this is the second stage, that is the propagation. Initiation is there by breaking the carbon double bond, that is the initiation. In the propagation, that free radicals will get attached or they will form the chain to the adjacent molecules, that is the propagation. And in the last stage, there will not be any free radical, then that process will get terminated. Okay, that process will get terminated and this addition polymerization and chain type polymerization process will stop there. Okay, in this way, this addition polymerization works, and whichever new material will be formed, that you can see, for example, if ethene is there, okay, if ethene monomer is there, and after polymerization process, your resultant material is polyethylene, or in short, the polyethylene. Polyethylene is the practical example, whichever plastic carry bags we are using in our day-to-day life. That is polyethylene material. Okay, it is formed by the polymerization of ethylene or ethene. Are you getting this? This is the practical example. I will try to explain it again. You can see these steps. Initially, this is the ethene. Then, by using the catalyst, the double bond is broken and free radicals are formed, and these free radicals are combined. Means from ethene, at the end polyethylene is formed. Ethene and ethylene is same material. Okay, so and it is represented in this form. Okay, as a number of ethene molecules, n number of ethene molecules are there. I have written here n number of ethene molecules. Then due to polymerization, these types of chains are formed. Okay, so this is the addition polymerization process. Okay, remaining part we will try to cover in the next session. Okay, in this today's session, we have completed the additives and different kinds of additives used in the plastic. Then what is the monomer, what is the polymer, and in that we have discussed the different types, and from that we have discussed the addition polymerization along with the 3 stages, that is initiation, propagation, and termination. Okay, in next session we will discuss remaining types. If you are having any questions, you can ask me, or you can ask to the chat box. Otherwise, you can put your roll numbers in the chat box for your attendance. Okay, if you are not having any query, we will stop here. In next session, we will complete the condensation, coordination, and copolymerization. Thank you for attending this session. Thank you.